All right, today this is section 8.4. The purpose of the lesson is to do real world problems and solve them using systems of equations. Before, when I was teaching you guys, we were learning everything, and we learned how to solve word problems using one variable. Since we're in the systems of equations, we're now going to write our equations with two variables and solve using the methods that we've already learned, which are substitution and elimination. I'm really quickly going to just show you. Here's one where they're actually solving graphically. Marty has $45 and is saving $2 a week. Wayne has $12 and is saving $5 a week. My unknowns are what? Who can tell me what my unknowns are? What's changing? What are the variables? Yes.
The weeks.
The weeks are changing and the money is changing. What depends on what? Does the money depend on the weeks, or do the weeks depend on money? Yes.
Money depends on weeks.
Yep. So if money's the depender, it is the Y. We'll say that X stands for weeks and Y. You don't have to write this. Most of tonight's, I just want to show you an example of solving by graphing. So the equation for Marty, who knows what that equation will be? If Y is the savings, what will the equation be if Marty has a starting point of $45 and is saving $2 per week? What would the equation be? What do you think? Yeah.
Y equals 45 plus 2x.
Yep. So my savings is equal to the starting point, the starting balance of 45 plus 2 times the number of weeks. What would Wayne's equation be? Brianna.
Y equals 12 plus 5x.
Y equals 12 plus 5x. So if I could graph this, right? On my graph, on the y-axis, what's it going to be? On the y-axis, what's it going to be? Yep. Savings. And on the x-axis, it's going to be our weeks. So I could create a table and say after 0 weeks, 2 weeks, 4 weeks, figure out what I'm going to get. Now, if you notice, I have to get at least to 70 here. That's how I knew my scale should be. My scale should be by... All right, so you notice I have to go up to 70, and for my weeks, I'm going up to 12 weeks. Remember, my scale doesn't have to be the same. So I plot each point. 0, I have $45. At 2 weeks, I'm going to have $49, and so on and so forth, right? And when I have Wayne, I'm going to do the same thing. Plug it into the equation, plot the points. And who can tell me what the solution would be to this system? Because this will help you for your quiz. Given a graph, what is the solution to the system? Nobody? Fionn.
11, 65.
What does that mean, 11, 65?
11 weeks and $65.
At 11 weeks, they will both make $65, right? If you put it into the ordered pair, 11, 65. Does everybody understand it? And let's go back to the question. So really the question is saying, really the question is saying, oh my gosh. Really the question reads, let's go back. Write a linear equation to represent the doesn't really ask us to find anything. So, anyways, but this is what on the test tomorrow or on the quiz, I will be asking you to solve the system. Now, I've solved it by graphing here, but we can also do the same thing and solve through substitution. Right? Substitute it in. Find X, and I get X is at 11 weeks. Do I have the ability to find the Y, the savings, what they'll have?
Yeah.
Substitute it into either original equation, and then we will have. So this is an example of solving it in two different ways. We're actually going to start with age problem. And I'm going to do, so here's an age problem. So I use these boxes a lot, and I'm going to ask that you use the boxes. When you have boxes, whatever you are comparing usually goes on the outside here. So read the word problem for us. Go, Gracie.
Jan is 16 years older than Barbara is now. In 4 years, the sum of their ages will be 50. How old is each now?
Okay, so now we are writing, what am I comparing?
Barbara and Jan.
Barbara and Jan. That's what goes on the outside of our box. Always, whatever you're comparing goes on the outside of the box. So I have Barbara and Jan. And we're talking about 2 time periods. When?
Now and in 4 years.
Now and in 4 years. Sometimes I say now and in the future. Now and in the past. This word problem happens to talk about 4 years ago, or in 4 years. Sometimes they talk about 5 years ago or 10 years ago. So our 2 time periods. What are we going to call Jan? What are we going to call Jan now?
X plus 16.
No, just Jan. Let's give her a name. We don't know how much she is. Yep. X. Or how about J for Jan? Right? I like J. What are we going to call Barbara? B. Okay, that's their names now. How would I call Jan in 4 years?
J plus 4.
J plus, oops, that's supposed to be a J, not a, okay. J plus 4. How do I call Barbara in 4 years?
B plus 4.
Good. So now what we're doing, we're going to start translating. What do I put for Jan?
J.
J is,
Equals.
was, will be means what?
Equals.
Equals. 16 older than
B plus 16.
So it's B.
Barbara, and it says now. When? Now. So I use these. So what am I going to do?
B plus 16.
B, since it says older than, that means older means plus. Than means I replace. So instead of doing 16, Nicole, instead of doing 16 plus, instead of doing 16 plus B, because it says than, it has to be B plus 16. Okay, that's the first one. Now look at this. For the whole next sentence, it says in 4 years. That means everything following, I have to call them by the 4-year name. The sum of their ages will be 50. What does sum mean? Add. So I'm adding in 4 years. What's Jan's name?
J plus 4.
J plus 4. In 4 years, what's Barbara's name?
B plus 4.
Will be,
Equals 50.
okay? Now what we have is Jan plus Barbara in 4 years. Their age will be 50. Okay, I'm set up very nicely to do what method? Substitution. So I'm going to substitute this for the J, and then I have B plus 16 plus 4, right? B plus 16 gets replaced with J, plus the 4 plus B plus 4 equals 50. So now I'm doing, I have 2 B's, and I have 8 and 16 is 24 equals 50. Subtract 24, subtract 24. 2B equals 26. Divide by 2, divide by 2. B equals what?
13.
So Barbara is 13 now. And then I can use that same thing, and I can substitute right here. J equals 13 plus 16. J equals 29. So that would be 29. So my answers are Jan. It says, how old is each now? I always go back. How old is each now? Jan is 29 years old. And Barb is 13 years old. Okay, questions? Okay. Can I erase? Yeah. Seems pretty easy. Just wait till you get to the word problems. Okay, you'll notice in my PowerPoint I used X and Y. The reason why I don't like to use X and Y is because when you get X, what does it mean? If you have J, you know J stands for Jan. Does that make sense? And when you're, stressed out and under pressure while taking a test, I think that, all right, you want to try the next one now? Sure. Pause the recording. You may talk to your table partners. You may ask for help from me. I'm going to ask one more time. What do we put on the outside of the box?
Mary.
Huh?
Mary.
No, both outsides, what we're comparing. Up top, it's going to be now, and in the past or the future. Whatever they're talking about. Past or future. Okay? Pause the recording. Try it on your own. All right, what am I comparing? What goes on the outside of the boxes? Yes.
Mary and Sarah.
Mary and Sarah. Okay, we are talking about now and when? 5 years ago. The time period is 5 years ago. So it's the age now and the age 5 years ago. What are we calling Mary now?
M.
What are we calling Sarah now?
S.
I use a hand because my S's and 5s look the same. What do I call Mary in 5 years?
M minus 5.
Good. And what do I call Sarah in 5 years?
S minus 5.
Okay. So now we are doing Mary is 18, older than Sarah. What's that equation?
M equals S plus 18.
Okay. 5 years ago. Now, new sentence. It started with 5 years ago. Anybody mentioned has to be mentioned by their name 5 years ago. How do I write Mary?
M minus 5.
Was,
Equals.
is, was, will be, right? Twice Sarah.
2 times the value of...
2 times her 5 years ago. 2 times the quantity of S minus 5. So now I'm set up for what?
Substitution.
So I'm doing S minus 18 minus 5 equals S plus 18 minus 5. And I'm going to distribute 2S minus 10. S plus 13 equals 2S minus 10. Let's add 10. I'm adding 10. I'm also going to, at the same time, subtract S, cancel. I get 23 equals S. So if M equals 23 plus 18. M equals 41. So I'm going to say Mary is 41. This one is 23. So Mary, 41 years old. And Sarah is 23 years old. Questions? How old is each now? Okay, yes, I'm understanding, or no? Okay, moving on to the next type. Okay, more boxes. Start writing. Actually, you're going to make it like 3 by 3. Okay? I'm comparing. Joe bought 15 items for $135. If the 15 items consisted of notebooks for $4.50 each and calculators for $12 each, how many of each did he buy? So step 1, I'm calling this, we're comparing notebooks. and calculators. So I'll call this, do we know how many notebooks? Oh, first column is about amount times the unit value, the unit value. In this case, the unit value is money. What units are they talking about? Is equal to, I multiply across and I get a product. Do you see that? And when I go up and down, I get a sum. Okay, so now I'm ready to fill my box. Do we know how many notebooks? So let's use a variable, n. Do we know how many calculators? So let's use a variable, what? Do we know the total?
Yes.
What is it?
15.
Good. There's an equation, right? Add going up and down. N plus C equals 15. Now, what's the unit price of a notebook?
450.
So it's 4.5, right? What's the unit price of a calculator?
12.
So I multiply going across. It's always going to be the same. So I get 4.5 N, and I get 12 C. And what do I do going up and down? I add. And so I don't really need this because I don't have a unit value of anything in that column, in that box. But we do have one more number. Notice there's money here, there's money here, there's money here. I'm missing the total cost. So the total money value goes down here. So now I really have my two equations. 4.5N plus 12C equals 135. Now, if I can solve this through elimination. Actually, let me just do this. I'm going to write it right down here. 4.5N plus 12C equals, what did we say? 135, right? The easiest one to clear is the 12. So I'm multiplying everything by negative 12. I'm then going to get negative 12N minus 12C equals negative 12 times 15. Is it 190? 180. Negative 180. The other one is 4.5N. Oops. Are you guys okay?
Yes.
Plus 12C equals 135. Okay? They cancel. I'm left with 750N equals, I have 545. I personally want to clear my decimal. Negative 45 and negative 7.5. I personally want to clear the negative and the decimal. I'm going to multiply by negative 10. Then I get 75N equals 450. 75 and 75 is 150. There are 3 150s and 450, right? Yep. So that means I divide by 75, divide it by 75, N is equal to 6.
Where'd you get 10 from? Negative 10.
Because I want to move a decimal. I can do anything as long as I do it to both sides of the equation. So if the notebooks are 6, what are my computers? I go back to N plus C equals 15. Let's hold on. 6 plus C equals 15. Subtract 6, subtract 6. C equals what? 9. And you need to put it like in word form. Well, you don't need a full sentence, but you need to say notebooks. We had 6 notebooks and 9. Hold on, please. I'm recording. So they use X and Y. I personally prefer you to use N and C so you know what you got. Okay, so, oops. 6 notebooks and 9 calculators. Okay, wait, stop. I want to hold on. I want to just go to the next one really quick. Tell me how to set up this box. Myrna raised $24 by selling 40 baked items for the Builders Club. She sold cookies for 50 cents each and brownies for 75 cents. Okay, on the outside, what do I put? Go.
Cookies and brownies.
Cookies and brownies. Okay, the top we're talking about amount times the unit rate, which it's dollars. I told you it's dollars, is equal to the product. So what goes in the first box for cookies? Raise your hand. Yep. C. My PowerPoint's going to do X, right? And the value of a cookie is how much? What goes under the 0.5? What goes in the next box below C? Okay, what is the unit value? Okay, what do I put in the bottom box under C and B? How much? 40. Multiply across, what do we get? And what goes in the bottom box? $24. Your two equations are right here. Got it? All right. If you want to keep watching. Now, my PowerPoint uses X and Y, but I really recommend using... Excuse me, I'm still taping. So I really recommend you keep using C and B. So we're filling in the unit value, the money. We don't know how many cookies, so we call it X, or we call it C and B. We always multiply going across. And then we've got our two equations. X plus Y equals 40, and 0 and 5/10 X. Guys! And I've got 0 and 5/10 X plus 7,500 Y equals 24. Now, personally, I would get rid of the decimal, so I would probably multiply by 100. They're multiplying by -2. I would probably multiply both and just get rid of my decimals. So in this case, I'm multiplying by 100. I end up with 50x plus 75y equals 2,400. And then I'm probably going to multiply by the top one by -100. So I end up with not -100. I would multiply by -50. -50. So I get -50x minus 50y equals -2,000. Now, cross cancel, I'm left with 25y. Positive 25y equals 400, divide by 25, divide by 25, and y is equal to 16. So that means I sold 16 brownies, right? Just 400 divided by 16. Yep, 25. Wait. Whoops. 400 divided by 25 is 16. Yeah. So I have 16 brownies, and that means if I have x plus 16 equals 40, subtract 16, subtract 16, we have x equals 40 minus 16 is 24 cookies. That is what we sold at the bake sale. All right, so you can see here they chose not to clear the decimal, which is fine. You should still get the same amount. All right, so that's the lesson.